This one is an unusual one. Now, what makes this one so unusual? Well, we can see there are some numbers highlighted in red, and the others are highlighted in black. Now, the numbers in red follow an arithmetic progression. It goes 1, 2, 3, 4, 5, 6, 7, 8. So that's an arithmetic progression with a common difference of 1. The numbers in black go 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. So that's a geometric progression with a common ratio of 2. And we see that this series in front of us right over here is the result of taking a term from our arithmetic progression and pairing it up with a term in our geometric progression. So the first term is 1 times 2 to the 0. The second term is 2 times 2 to the 1. And it goes all the way to 8 times 2 to the 7. So how can we find the sum? Well, one way to solve new problems that you've never seen before is to compare these new problems to similar problems which you already know how to do. Now, because this series has a geometric component, let's see what happens if we try to solve this series in the same way that we solved a geometric series. So we can start off in the same way by calling this whole thing S. Now let's take a look at what happens when we multiply S by the common ratio of the geometric progression. Now, since the common ratio is 2, let's take a look at 2s. So 2s is the result of taking each term in s and multiplying it by 2. So 1 times 2 to the 0 becomes 1 times 2 to the 1. 2 times 2 to the 1 becomes 2 times 2 to the 2. 6 times 2 to the 5th becomes 6 times 2 to the 6th. 7 times 2 to the 6th becomes 7 times 2 to the 7th. And then 8 times 2 to the 7 becomes 8 times 2 to the 8. Now, let's take the difference between these two series. So we'll take 2s and subtract s so that we get s on its own. So 2s take away s will give s equals this term at the end over here is 8 times 2 to the 8. 7 times 2 to the 7 minus 8 times 2 to the 7 becomes minus 1 times 2 to the 7. 6 times 2 to the 6 minus 7 times 2 to the 6 becomes minus 1 times 2 to the 6. One times 2 to the 1 minus 2 times 2 to the 1 becomes minus 1 times 2 to the 1. And then we need to subtract this last term at the end over here, 2 to the 0. So that's another advantage of writing these series out like this and lining our powers of 2 up with each other, because when we take the difference between these two series, it just makes things a little easier to see. Now, the good news for us is that this portion over here is just a geometric series, which we already know how to solve. And if you don't remember how to evaluate the sum of a finite geometric series, an infinite geometric series, or any geometric series really, I would recommend reviewing those and then coming back to this video. I've already made videos on finite geometric series, so I would recommend checking those out. But once you do some calculations, you'll find that S ends up being 1,793. So the big takeaway from this problem is I want you to realize that we were able to evaluate the sum of this funky series in the same way that we solved a geometric series. Now, this funky series right over here actually has a name. This kind of series is called Arithmetico-Geometrico. Because it's the result of taking an arithmetic series and a geometric series and combining the two. So this is just another example of using the same technique to solve a new kind of problem. Now the example we did today was just a finite Arithmetico-Geometrico, so it stopped after a certain number of terms. But just like geometric series, Arithmetico-Geometrico series don't have to just be finite. So you can probably guess what's coming next.